Hi guys, and welcome back. First of all, thank you for watching the videos. We're almost on 100 views for one of the videos. So let's get straight to it. Today we're going to talk about Lewis structures. What is a Lewis structure? It's a graphical representation of the arrangement of electrons around an atom or a molecule or a compound. So how the atoms are drawn graphically, so we can see where they are placed around the atoms. Okay, so some examples. We've got phosphorus trichloride, water, carbon dioxide. You can see the 3D structures and then the Lewis structures. Okay, let's get straight to an example. I want to look at a polyatomic ion. A polyatomic ion is two atoms. We've got the phosphorus and the oxygen bonded together with a charge. An ion is something that is charged, either it's lost or gained electrons. In this case, it's -3, so it's gained 3 electrons. First thing we need to do is work out the valence electrons. We need a periodic table. Phosphorus is in group 5 plus oxygen is in group 6, but there's 4 of them, so multiply that by 4, put that in a bracket, plus the 3 electrons. Remember, when it's minus, it's the opposite. We actually add the electrons. Do not make that mistake of minusing the electrons. So let's do the calculation. 6 times 4 is 24, plus the 5 is 29, plus the 3 equals 32 valence electrons. Now, if you remember the equation that we used before to work out lone pairs equals valence electrons minus 8n divided by 2. Now, n is the subscript, which is 4, and 8 is the octet rule in terms of 8 electrons there. So if we do the maths here, it is 32 minus 32, which equals 0, divided by 2 still equals 0. Okay, so the lone pairs are equal to 0. That we've established, we've got 32 valence electrons and the lone pairs are equal to 0. Now I just want to introduce another equation. This is to work out how many bonds we have. So bonds will equal the valence of the central atom, which is the phosphorus, which is going to be 5. This is the valence of the central atom minus the 0 that we had there equals 5. So we know we're going to have 5 bonds. Okay, now let's draw this 5 bonds. We're going to draw this now. So central atom phosphorus, we know we have 4 oxygens. So here's 1, 2, 3, 4. Let's put the oxygens in there for now. Okay, we said there are 5 bonds. Okay, so we need to add another bond. So we need to make a double bond. Here we go. Now let's add the valence electrons there. So we know the single bonds will have 1, 2, 3, 4, 5, 6 on each one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because it's a double bond, we're only going to have 4. Now, there is the Lewis structure. Now, how do we know this is correct? One more thing I want to show you today is called formal charge. How do we work out that this actual polyatomic ion has a charge of -3? First thing, this is the equation we want to use. So formal charge, Fc, equals, so let's look at this. How many electrons? What's the valence electrons? 1, 2, 3, 4, 5, 6. So it'll be 6 minus, let's put this in brackets now, the one bond, the single bond, plus 6, which is the valence electrons, right? Or the dots, as we say. This will equal -1. So each one of these will be -1, -1, -1. Now if we do the same thing over here, we've got 6 minus, we've got 2 bonds, plus we have 4 dots. Okay, this will equal 0. So the overall charge is minus 3, which adds up. Now there's the example for this polyatomic ion. Now let's look at another example. So let's choose something different. What shall we look at? Let's look at the carbonate ion. It's another polyatomic ion. So let's write down the formula first. We have CO 3 2 minus. We'll do the usual 4 electrons, valence electrons, plus 6 times 3 plus 2, because it's 2 minus, right? Total will be 6 times 3 is 18, plus 2 is 20, plus 4, 24. Okay? Now, let's work out lone pairs. So lone pairs equal valence electrons minus 8n divided by n. Now, a bit of quick maths here. It's going to be 24 minus 24, which equals 0. So we've got 0 lone pairs again. Okay, divided by 2. This equals 0 lone pairs. Now, working out how many bonds we have, again, let's get used to doing this. Bonds equals valence of the central atom, which is 4 minus 0 equals 4 bonds. So we know we've got 4 bonds, right? Let's draw this again. So the central atom, carbon, we've got 3 oxygens, 1, 2 and 3, but we said we have 4 bonds, so again it's another double bond. So let's draw the oxygens. Okay, so now we want to add the dots again. So we have the single bonds will have the 6, 1 2 3 4 5 6, 1 2 3 4 5 6. Let's do this again, 1 2 3 4, because it's a double bond, right? Now we said the last thing, the formal charge, right? Formal charge. The formal charge will equal, we know the oxygens, we have 6, okay, minus, we have 1 plus 6 dots, which equals minus 1, and that will be the case for both oxygens here, minus 1. We know this oxygen will have 6 minus, there's 2 bonds, plus 4 dots, okay, equals 0. So the overall charge here is minus 2, because we have 2 of these, right? So that is the Lewis structure correctly drawn with the charges for the carbonate ion. I hope this helps, guys. Any questions, just put them on the comments and I will do another video. Thank you. Bye.